Alg2 students, Mrs. Myers here. We are taking a look at the second day of lesson 15, which is to use Pythagorean identities to do evaluating with trig expressions. So let's review what those Pythagorean identities are, not how we got them, I already did that, but just what they are, okay? So there are three, okay? So our first Pythagorean identity is sine squared theta plus cosine squared theta is equal to 1, okay? Our second Pythagorean identity is, and remember, we could just divide everything through by cosine squared theta to get to the next one. That is tan squared theta plus 1 equals secant squared theta. And our third, okay, if we just go back to the original and we divide everything through by sine squared theta, we'd get 1 plus cotangent squared theta equals cosecant squared theta. Okay, so those are our three Pythagorean identities. And remember with each one of them that the sine squared theta really means sine theta quantity squared, the cosine squared theta really means cosine theta quantity squared, etc. Okay, so let's just write that down, that these are your Pythagorean identities. Okay, so we are going to evaluate using these Pythagorean identities here. So we got three examples to go through. We'll do one for each one. You're going to see it's very, very repetitive. So once we go through the first one, that's the main gist of it. But, you know, it's going to be worth, I think, practicing a couple times over to make sure we really got the hang of it. So if I tell you, okay, so if I say to you, if sine theta is equal to -1/3, okay, and I gave this lovely little statement right here that says 3 pi over 2 is less than theta, okay, which is less than 2 pi, and then I say find cosine theta, okay, that's basically saying, you know, what is the value of cosine theta given the value of sine theta. Now, hopefully you'll notice right up here that sine theta and cosine theta are together in the same Pythagorean identity. So we're going to use that, okay, we're going to use sine squared theta plus cosine squared theta, whoops, is equal to 1. And we're going to make a substitution. Now, this really means, okay, sine squared theta really means sine theta quantity squared, okay? So I'm going to make a substitution like this, -1/3 quantity squared. And then I leave plus cosine squared theta equals 1. And now I'm going to evaluate, okay? So if I have -1/3 quantity squared, that is now 1/9, okay? Just -1/3 times another -1/3, positive 1/9. And from there, I'm going to minus the 1/9 to each side, okay, and that's going to give me cosine squared theta equals, now what is 1 minus 1/9? So if I change 1 into the fraction 9/9, I can see that that's 8/9. And then, I'm trying to find out what cosine theta is, right? I'm going to get rid of the squaring by square rooting, and I've got cosine theta equals square root of 8 over the square root of 9, because I'm going to separate that square root over the numerator and denominator. Now, don't forget that when you have the square root that's been introduced into the equation, you need to account for plus and minus. Okay, we're going to come back to that in a moment, okay? But anyways, let's take a look at these values. Well, in the denominator, square root of 9, that's exactly 3, okay? And in the numerator, square root of 8, okay, well, square root of 8 is the same thing as square root of 4 times square root of 2, so that can simplify into 2 square root of 2. Now, back to that plus minus, okay? Any trig function value, okay, for any particular angle is either going to be positive or it's going to be negative. It's not going to be both positive and negative, so that doesn't really make sense to have that both there, so you got to pick one or the other. Now, how we know which one to pick is all based on this, okay? This really is just a statement telling you which quadrant your angle is in. And if you remember, there are these lovely 4 letters, okay, that tells you which function is positive in each quadrant. Now, this is just a way of saying that you're in quadrant 3, because when you start out with this rotation, okay, this is 0 radians, this goes to pi over 2, then this is pi, then this is 3 pi over 2, and then finishes up your rotation at 2 pi. So if you're somewhere between 3 pi over 2 and 2 pi, you're in the 4th quadrant, okay? Now that makes sense as to why this sine theta value that was given to you was a negative, because sine theta is negative in the 4th quadrant. And the fact that I want you to give me the value for cosine theta, and I'm in the 4th quadrant with my angle theta, tells us that of these two, we're going to pick the positive. And now I have my final answer. All right, so that's the process, and let's just try it 2 more times for the other two Pythagorean identities. Okay, so if I say to you, if secant theta is equal to negative square root of 7 over 2, and pi is less than theta, which is less than 3 pi over 2, find tan theta. All right, so which Pythagorean identity should we use? Okay, well, secant and tangent are together in that Pythagorean identity, so I'm going to write it down. Okay, tan squared theta plus 1 equals secant squared theta. Now I'm given secant theta as negative square root of 7 over 2. Remember, secant squared theta really means secant of theta quantity squared, so I'm going to go negative square root of 7 over 2 quantity squared. Okay, so now let's square this. Okay, so we got tan squared theta plus 1 is equal to, so squaring a fraction means square the numerator and square the denominator. So squaring anything that's negative will automatically be positive, and squaring the square root gets rid of the square rooting, so that's just plain old 7 over, and that's going to be 4, right, because 2 squared that gives you the 4. Now I'm trying to find out what tan theta is, so let's isolate tan squared theta by minusing 1 to each side. Now to subtract 1 from 7/4, let's take number 1 and turn it into 4/4. So that subtracts to be 3/4. Okay, and then to get rid of the squaring, let's do the square rooting. So now I've got tan theta equals, and if I've got the square root of 3/4, so it's square root of 3 over square root of 4. Well, square root of 4 is just 2. So how about we just kind of do that in our heads? Now remember, you really have to include plus and minus because you introduce a square root, but you can't keep both. I mean, tan theta is either going to be positive or it's going to be negative. Now, which should it be? Okay, so let's go back to this. Okay, again, each trig function is either positive or negative, depending on which quadrant you're in, and it's very helpful to think of these 4 letters to know which function is positive, and therefore you know which is negative. And this is telling you, okay, that you are in quadrant 3, right? See how I put this before? See the radian measures that I put there? This is telling you that you're in quadrant 3, to be between pi and 3 pi over 2, right? So that explains why secant was negative, because only tangent's positive in this quadrant, okay? But that means now that this answer should be a positive value, okay? So let's write down our answer as positive square root of 3 over 2. Okay. One more, okay, one more for the other one. And if I say to you, if cotan theta is equal to 1/3 and pi is less than theta is less than 3 pi over 2, okay, find cosecant theta. All right, so we are going to figure out which trig Pythagorean identity uses these 2 trig functions. Okay, so cotangent and cosecant, pardon my boiler, and that's this one right here. Okay, so I'm going to write that one down. Okay, I'm going to jot down 1 plus cotangent squared theta is equal to cosecant squared theta. Now, I know what cotangent theta is equal to. It's 1/3. Remember, this really means cotan theta quantity squared. Okay, so I'm going to go 1 plus 1/3 quantity squared equals cosecant squared theta. So 1/3 squared is 1/9. Okay, 1 plus 1/9 is 10/9. Okay, so now I don't have any adding and subtracting to do like I did with those other ones because I'm trying to find cosecant theta, and cosecant squared theta is already by itself. So all I really have to do is make substitution here, do this adding that's already right there on the left-hand side, and get rid of the squaring by square rooting. And what does that mean about cosecant theta? So if I'm going to square root a fraction, I'm going to square root the numerator, square root the denominator. Square root of 9 is 3. And of course, I would always include plus and minus when I am introducing the square root to solve an equation. But I can't keep both positive and negative. Okay, which should it be? Okay, should cosecant theta be positive square root of 10 over 3 or negative? So let's go with this. Okay, so this tells us, okay, once again, that we're in quadrant 3. Okay, so if we are between pi and 3 pi over 2, we're in quadrant 3. And that explains why cotangent was positive, because it's the reciprocal of tangent, and tangent is positive in this quadrant. But what does it mean about cosecant theta? It means that it should be negative. All right, so there's my answer this time. It should be a negative square root of 10 over 3. All right, so that is the end of lesson 15, day 2. Again, different flavor than the 15-day 1, but it is still the same lesson in the sense that it's using the Pythagorean identities. It's just using them in a different way. All right, so I hope you have an okay time with this homework, and then there's just one more lesson to go, lesson 16, okay, and that'll be our next lesson. All right, hope everyone is doing well. Bye.